Hi guys, so welcome to Unit 7. In Unit 7, we are covering something called tests of significance. These are another process in which we sort of make conclusions and tell the story about an entire population given just sample data. So last unit we talked about confidence intervals in which we estimated for a population parameter. And in this one, tests of significance, we are testing a claim about a population to see if it is statistically significant. And we do so using our sample data. So that's what a significance test is. It's a procedure in which a claim made about a population is tested using sample data. And so, for example, let's say a basketball player claims to make 80% of all of his free throws. To test this claim, we take a random sample of 50 free throws, and he makes 32 of the 50, which is 64%. So as of now, the evidence we have seems to disprove his claim. Okay, the claim was that he makes, I'm sorry guys, 80% of his free throws. Okay, now the sample data that has been collected is X bar, or no, not X bar, P hat, sample percent, which was 0.64 or 64%. And that is what was collected to test this claim. All right, so today we're going to be talking about bits and pieces of a full test of significance. And then as we start to do them in full, you'll see these all come together. And so one of those first important things is a hypothesis. In fact, every test has two hypotheses. The first one is the claim that we are testing. We call that the null hypothesis. And then the claim we hope or suspect to be true instead of the null hypothesis is called the alternate hypothesis or alternative hypothesis. And so in that free throw shooter example, here would be our hypotheses. So HO, this is always the null, HO, and that is the claim, right? So he claimed that P, his population percent for all of his free throws, is equal to 80%. Based on our evidence, we think that the alternative or the alternate hypothesis, HA, would be that P, the population percent of free throws, is less than 80%. All right, so HO and HA are the null and the alternate hypotheses. All right, so the null will always have the form HO. It might say that P equals some number, or if we are looking at means, it would say that mu equals some number. But always, the null hypothesis says that some, either P or mu, is equal to a claimed value. Whereas the alternate takes on the form P is less than that same number, or P is greater than that same number, or P does not equal that number. And you could do the same with mu. All right, so we have three options for the alternate, only one for the null. The null is always equal. Okay, so here it says the newspaper reports that 32% of all Hilliard City School students participate in extracurricular activities. Dave Stewart thinks that percent is incorrect, but he is unsure about the actual percent being larger or smaller. That's really important. He takes a sample of 100 students and runs a significance test to check the newspaper's claim. So the parameter he is looking for is the percent of all HCSD students who participate in extracurricular activities. All right, so then our hypotheses would say the null HO would be P, because this is a percent, is equal to 0.32. That's the claimed value for P. Whereas his alternate would say that P, because it said he is unsure about the actual percent being larger or smaller, would be that it does not equal 0.32. Could be bigger, could be smaller, it's just not 32%. All right, so those are the hypotheses. Now we're going to jump all the way to one of the last steps, which is p-values. So we use p-values to decide the conclusion of our significance test, and it is something that we calculate. The p-value, this is a really important definition, is the probability of getting the result we got when we assume the claimed value is true. Okay, so let's say for the basketball example, the p-value would be the probability he shoots a 64%, getting the result we got, 64%, when we assume he can actually get an 80%. And so if you think about this, in the end, a p-value is a probability, it's a percent. And if that percent is really small, then we shouldn't have assumed that the claim value is true. So small values tell us that the observed value is unlikely if the null is true, meaning that the null is not true. So small p-values disprove the null hypothesis, whereas large p-values tell us that the observed result could be likely if the null is true, meaning that our test is inconclusive. So there's not really a way to prove that the null is true. Instead, we just say we can't say anything. We are inconclusive. But we can prove or disprove that the null is true by proving that it's wrong. And that's with a small p-value. So from that newspaper example, we said that our null hypothesis, HO, was that P is 32% of students. And our alternate was P does not equal 0.32. All right, so let's say they run this sample of 100 students and find that 52 students are involved in extracurricular activities. So P hat, our sample percent, is 0.52, much different than 32. Upon running the significance test, they find a p-value of 0.10. 0.10. Interpret this p-value in the context of the problem. So remember, that's a probability. So the probability, I'm going to scroll up so we can see this, of getting the result we got. So of getting 52% when we assume P equals, well, let's put it in percent. So 32% is 0.10 or 10%. All right. 10% is not huge, right? It's relatively small. And so what that tells us is maybe we shouldn't make the assumption that it's actually 32%. Maybe that's the wrong claim. And so therefore, maybe we have disproven that claim, instead saying it might actually be bigger or not equal to 32%. Okay? And so after that p-value, we draw a conclusion. And to make a final conclusion, we use what's called a significance level. So remember confidence levels? Well, we have significance levels. And a significance level is noted using the Greek letter alpha. So it looks like this guy. And it sets a bar that allows us to decide if our p-value is small or large. So it says any p-value greater than this significance level is considered big, and any p-value less than this significance level is considered small. So if your p-value, this is a really important box, is less than your significance level, then we say for our conclusion that we reject the null in favor of the alternative. So we disprove the null hypothesis. Remember, that's the goal. You want to prove that the claim is wrong. You want to prove that the null is untrue. However, if your p-value is more than that, then it's high, and we have an inconclusive result. We fail to reject the null hypothesis. Okay, you might press pause there, rewatch it, because that's a really important piece. So if we come down here, it says a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, These new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows that its new batteries are only considered effective enough to sell if they last 25% longer than the regular AAA batteries. The company selects a simple random sample of 100 new batteries and uses them continuously until they are completely drained. So, a significance test is performed using these hypotheses. So, the claim is that it's equal to 25 because we want to prove that P, the percent longer, is greater than 25%. Right? Remember, the null always has to be equal, whereas the alternate takes on the less than, greater than, or not equal to. All right, P is the true percent of performance time that the new batteries last compared to the regular batteries. So how much more or longer they last than the regular. And our resulting p-value is 0.0276, so 2.76%. First, we're going to interpret that p-value. So we would say the probability of getting now we don't have the observed results, so we're just going to say that. If we had the sample percent, we would use that. When we assume P equals 0.25 is 2.76%. All right, now if our significance level was 0.05, we are comparing that to a p-value of 0.0276. The p-value is less than that, so the p-value is less than the significance level, so we reject the null in favor of the alternative. I always call it alternate. All right. Now let's say that significance level was only 0.01 and our p-value is still 0.0276. Well, now the p-value is greater than that. So the p-value is more than the significance level. So here we would fail to reject the null. Okay, so I hope that helped you learn some of the beginning parts of tests of significance. Go ahead and work on that practice and use the key or your group to check your answers.